Good morning, dear students. So, as we know that in the mid-19th century, the scientists of the world were struggling. Okay, they were struggling for what? They were struggling for classifying elements. And we have seen that Frobenius tried failed, and the Newton's law of octave was also not able to satisfactorily classify all known elements of that time. So after a few years, what happened? After a few years, a Russian scientist, his name was Dmitry Ivanovich Mendeleev. So what he did, he proposed a scientific marvel, and that became a milestone in the history of classification of elements. Okay, so let us study about his work. Okay, so during the time of Mendeleev, 63 elements were known. Okay, and he tried to establish relationship between all the elements by finding their physical and chemical properties. So for this purpose, what he did, he made these elements react with oxygen and hydrogen. Okay, so you might be wondering that why he selected oxygen and hydrogen for this purpose, because we know that oxygen and hydrogen are very reactive, no, and they can easily form oxides and hydrides, and they can also form compounds with most of the elements. So this was the reason behind his selection of oxygen and hydrogen. Okay, so after that, what he did, he made card for each and every elements, for all the 63 elements, and in the card was like your ID card. In your ID card, your date of birth, your class, section, roll number, all the things are written. No, so in those cards he has written all the properties of the elements. Okay, and he then pinned the card in the wall. He pinned the card in the wall on the basis of what? On the basis of their increasing atomic masses. Remember, increasing atomic masses. And he found some recurrence of what? Recurrence of physical and chemical properties. He saw that after certain intervals the properties repeat. So on that basis he proposed his law. What does his law say? The properties of the element are the periodic function of their atomic masses. So let us break the statement and understand. The properties of the element are periodic function. Periodic means they occur after certain intervals. Okay, so that means if we arrange the elements on the basis of their increasing atomic masses, we will see that after certain intervals the properties get repeated. So this was the law of Mendeleev. Okay, and in our next video we will study this table of Mendeleev. Okay, so see the next video. Let us now learn about the limitations of Mendeleev classification. So let us study it with the help of this table. So see, the first limitation is that elements with large differences in properties are kept together. For example, see copper. We know copper is the hard metal, and lithium, sodium, these are soft metal. So these are kept together, no? So this is a shortcoming of the periodic table of Mendeleev. The next one is no proper place for hydrogen is there. Okay, so hydrogen is what? Hydrogen is a non-metal. We all know that hydrogen is a non-metal. So non-metallic hydrogen is kept with what? Is kept with lithium, is kept with sodium, which are metal. So this is a shortcoming. And the third one is that, see, I have already told you this is a shortcoming also, and for him it was an achievement. See, these are arranged in the inverted way, because we know that they should be arranged in the increasing order of their atomic masses. So this was not followed by him, although he considered it to be achievement, but in the modern science it is considered to be as the drawback. Okay, and the final one is, it is very important, because see, isotope. We know what is isotope. Isotopes are what? Isotopes are element with similar chemical properties but different atomic masses. Okay, so see, there are no place for isotope in the table. So this was the limitation. The first limitation is that element with huge difference in their properties are kept together. Number two is that there is no place for hydrogen in the table, no proper place. It is a non-metal, is kept with the metal. So this is a drawback which is very easily observable by a layman also. And the third one is that there is no place for isotope. Isotope means elements with similar chemical properties but different atomic masses. So there is no place. Isotopes cannot be placed in the periodic table prepared by Mendeleev. And the final one is that in case of certain metal, he violated his own law, that is arranging them in increasing order of their atomic masses. So with this we have completed the Mendeleev periodic table. We have learned about its the statement, the achievements and the limitation also. So next day we will do the question and answer from the same topic. So this is the periodic table of Mendeleev. His table consists of how many groups? His table consists of 8 groups and 6 periods. These vertical columns are called groups and these horizontal rows are called periods. So see, can you see the letter R? So here R represent what? The R represent the element and the formula represent the formula of the compound that is formed when the element reacts with what? Element react with oxygen and hydrogen. Okay, so after doing this he arranged them on the basis of their increasing atomic masses and he put it in a tabular form. Okay, now this is all about his table. So now let us learn about his achievements. Okay, achievements of Mendeleev periodic table. So let us see the first achievement. Okay, so see, cobalt and nickel. See, the atomic mass of cobalt is what? 58.93 and the atomic mass of nickel is 58.71. But I told you that they must be arranged on increasing order of their atomic mass. But see here it is inverted. Nickel have low atomic mass than cobalt. So nickel should be placed before cobalt in the periodic table, but it has been inverted. Why he did so? He did so to keep similar elements together, element with similar properties together. Okay, so this was the first achievement. Although he violated his own law, but he could keep similar elements together. Okay, so this was the first one. And now see the second one. The second one is about the vacant spaces in the periodic table. So see, there are certain vacant spaces in the periodic table. So he kept these spaces intentionally. Because why? Because he knew that elements will be discovered in the future. So one such example is of scandium, gallium and germanium. Okay, so he predicted the properties of the elements in the vacant spaces and he named them as Aka boron, Aka aluminum and Aka silicon. Okay, and in the future these were discovered. Okay, these were discovered and the properties which he predicted also matched. So these were named now as scandium, gallium and germanium. So see how accurate his prediction was. Okay, the last one is about the noble gases. Noble gases means the inert gases. So during his time most of the inert gases were not discovered. Okay, so when these gases were discovered, those gases could easily fit into his periodic table without disturbing the existing structure of the table. See, although there were no noble gases during his time, but when these gases were discovered later, they could fit his table easily. So this was his third achievement. So with this we have completed Mendeleev periodic table.